Good morning, friends. In the previous lecture, we were talking about the chapter Introduction to Trigonometry, and we have seen the first topic, that was trigonometric ratios. Right. So let us quickly discuss what trigonometric ratios are, and then we shall move on to the sums related to the trigonometric ratios. So as we have discussed in the previous lecture, that whenever you are using the concept of trigonometry, always you need a right angle triangle, and in this specifically this right angle triangle, we will take our angle C here, that means this vertex C as the reference angle. Right, we will take C or angle C as the reference angle. So with reference to this angle C, we get this side AB as the opposite side, this side BC as the adjacent side, and this AC as the hypotenuse, because we know that hypotenuse is the side opposite to the right angle in a right angled triangle. So we got these three sides, and we have seen the trigonometric ratios for different functions, for different, what we say this as, we can say this as trigonometric functions only, but what we say is this as the trigonometric ratios. So we got the first ratio, that was sine of C, sine of angle C, denoted as sine C, that is the side opposite to angle C divided by the hypotenuse, that is AB upon AC. See, I have written this ratios here in short, the last part that we have seen in the previous lecture. Right, so sine C, that is side opposite to angle C upon hypotenuse, which is AB upon AC. Similarly, cosine of C, denoted as cos C, that is side adjacent to angle C upon hypotenuse, which is BC upon AC. Similarly, the third one, tangent of C, denoted in short as tan C, which is equals to the side opposite to angle C upon side adjacent to angle C, which is AB upon BC. The fourth one was cotangent of C, that is cot C, that is side adjacent to angle C upon side opposite to angle C, which is BC upon AB. Then the fifth one was secant of C, that is sec C, which is denoted in short as sec C, that is having the ratio hypotenuse divided by the side adjacent to angle C, that is AC upon BC. And the last one was cosecant of C, that is denoted in short as cosec C, which is hypotenuse upon side opposite to angle C, that is AC upon AB. So these were the trigonometric ratios that we have seen in the previous lecture with derivation, with the fundamental that we had. Now we have also solved one of the sums there. Now again we are going to solve some sums related to this trigonometric ratios, and we shall move further. So we are having a question here, friends, that given tan A equals to 4 upon 3, find all the other trigonometric ratios. Whenever you will be asked the question in examination, you will be given one of the ratio. You will be given one of the ratio like this. This is the ratio tan A equals to 4 upon 3, and you need to find out the rest of the ratio. That means there are total 6 ratios. One will be given. You need to find out the remaining 5 of the trigonometric ratios. So let us see here that how this sum can be solved. Here it is given that tan A 4 upon is equals to 4 upon 3. Now friends, as we know that this is a ratio here, and what is the ratio of tan as we seen in the trigonometric ratios? Therefore we can say that side opposite to angle A upon adjacent to angle A is equals to 4 upon 3. We can write it like this. Right, side opposite to angle A upon side adjacent to angle A, that is equals to 4 upon 3. Now for this situation, let us draw a figure here. Then after that we can judge what will be the remaining ratios. So let us take A here as our reference angle. Let us take B as the 90-degree angle and C as the remaining angle. So we got this triangle ABC with angle B as 90 degree. Now what is side opposite to angle A? This. What is side adjacent to angle A? That is this. right? So side opposite to angle A and side adjacent to angle A, we got these both here. Now, what do we require? We require the lengths here, but we are given the ratio. So what we are going to do? We are going to let this, assume this as K. See, assuming that the ratio is equals to K, therefore, side opposite to angle A is equals to 4K, which is equals to BC. This is my side opposite to angle A, right? And side adjacent to angle A, that is 3K, which is equals to AB. Yes or no? So we got this, both the sides BC, we got it as 4K, we got AB as 3K. Is this clear or not, friends? This AB and BC, we have written it from the figure, that is BC equals to 4K and AB equals to 3K. Is this thing clear? Now, to find out the remaining ratios, first of all we will require the third side, and that is the hypotenuse. Therefore, in triangle ABC, angle B is equals to 90 degree. Therefore, AB square plus BC square is equals to AC square. That can be written by the Pythagoras Theorem, right? This can be written by the Pythagoras Theorem. So we are having AB, that is 3K. We are having BC, that is 4K. Therefore, 3K square plus 4K square is equals to AC square. Hence, 9K square plus 16K square is equals to AC square. This implies AC square is equals to 25K square, and which is equals to AC is equals to 5K, taking square roots on both the sides. So we got the length of the AC, that is 5K. Now here, friends, we got all the three sides of the triangle, so it will be easier for us now to find out the remaining ratios. Therefore, the remaining trigonometric ratios are, first of all, we will find out sine A. What is the ratio of sine A, friends? The ratio of sine A is side opposite to angle A upon hypotenuse. So what is the side opposite to angle A? BC. So sine A, that is equals to BC upon AC. Yes or no? That is the trigonometric ratio for sine A, side opposite to angle A upon hypotenuse. So what is BC here? That is 4K. What is AC? 5K. K and K is cancelled, that is 4 upon 5. So this implies sine A is equals to 4 upon 5. So we got the first remaining ratio. We got the first ratio as sine A, that is equals to 4 upon 5. Similarly, we shall find out the second one, that is cos A. The ratio for cos A, friends, is side adjacent to angle A upon hypotenuse. So what is side adjacent to angle A? AB. So we will get cos A, that is AB, divided by the hypotenuse, that is AC. So that is AB upon AC. What is AB here? 3K divided by AC, 5K. So K and K can be cancelled, which is equals to 3 by 5. Hence cos A is equals to 3 upon 5. We got the second ratio, friends, that is cos A, that is equals to 3 upon 5. Right. So similarly, we can find out the rest of the ratios also. Now the third ratio tan A is already given, so we are not going to find out the third ratio. Similarly, finding out the fourth ratio, that is cot A. Cot A, friends, side adjacent to angle A divided by side opposite to angle A. So we will get this as AB upon BC. AB is equals to 3K and BC is equals to 4K. So we can cancel out this K and K, which is equals to 3 upon 4. This implies, sorry, my mistake friends, not 10, cot A is equals to 3 upon 4. So we got the third remaining ratio here. Cot A is equals to 3 upon 4. Now friends, we have seen in the previous lecture that tan and cot are inverse of each other. So you can see that tan A is given as 4 upon 3 and we got cot A as 3 upon 4. So this both are reciprocal of each other or inverse of each other. Is this thing clear? So that is how we get the ratio for cot A. Similarly, sec A. Sec A, that is hypotenuse divided by the side adjacent to angle A. So what is hypotenuse here? Hypotenuse, that is AC upon the side adjacent to angle A, that is AB, that is equals to 5K divided by 3K. So let us cancel this K and K and that will become 5 upon 3. So we get sec of angle A, that is 5 upon 3. So we got the fourth remaining ratio, and as we seen in the previous lecture, cos and sec are also opposite of each other. So we got cos A as 3 upon 5 and we got sec A as 5 upon 3. Is this thing clear? So we got the confirmation that these both functions, these both ratios are reciprocal or inverse of each other. And the fifth one, that is cosec A, which is equals to hypotenuse divided by the side opposite to angle A. Hypotenuse divided by the side opposite to angle A, that is AC upon BC. So what is AC, friends? 5K divided by BC, that is 4K. K and K can be cancelled, which is equals to 5 upon 4. So this implies cosec A is equals to 5 upon 4. Is it clear? So we got the fifth ratio also, and as we can see here that sine and cosec are also inverse of each other or reciprocal of each other. So that is being confirmed that tan and cot are reciprocal of each other, cos and sec are reciprocal of each other, and sine and cosec are reciprocal of each other. And here we got all the 5 different ratios that are remaining for the given trigonometric ratio tan A equals to 4 upon 3. Okay. Take a look over it. Okay, so let me erase this all. I'm having a question again, that a triangle is given. I'm having a triangle is given to me, and in that triangle C is a right angle triangle. In triangle ACB right angled at C, in which AB equals to 29 units, BC is equals to 21 units, and angle ABC is equals to theta. Friends, this is called as theta. That is the notation for an angle. That is the notation for an angle, theta. Right? These are given, then determine the values of the first one, that is cos square theta plus sin square theta, and the second one cos square theta minus sin square theta. We are given this three things. The first one is triangle ACB, right angle at C, AB equals to 29, BC equals to 21, and the third one, that is ABC equals to theta. So first of all, on this question, let us draw a figure. Right angled at C, so we will take C as this B, and we shall take A here. Right? First of all, let us denote this. ABC equals to theta, so that is my angle ABC, which is theta. So, friends, as we seen that in the previous ratios, we were taking sine of B, cos of B, sine of A, cos of A, and all. Now we are having that angle named as theta. So we will write down sine theta, where theta is the angle between ABC. So sine theta is again opposite side divided by the hypotenuse, right? So we will take that sine of C or sine of A as sine of theta now. Okay. Now we are given the lengths here, that AB equals to 29 units, BC is equals to 21 units, and the third side is not given. So we will find out the third side as, let us see the solution now, that as triangle ACB is a right angled triangle, at angle C. As triangle ACB is a right angled triangle at angle C, AC square plus BC square is equals to AB square. This can be written using the Pythagoras theorem, that square of the sides making right angle is, sum of the squares of the sides making right angle is equals to square of the hypotenuse. AC is given, not given. Therefore, AC square plus BC square, that is given. So we will write down as 21 square is equals to AB square, that is 29 square. Is it clear? So this three things are given to us here. Now we need to find out the second one. What is the second one here? We need to find out AC square. So what is, friends, first of all we need to find out 29 square. So let us find out what will be 29 square. What is 29 square? You need to know this. What is 21 square? What is 29 square? You need to know all the values here. Therefore, AC square plus 21 square is 441 is equals to 29 square is 841. Right? Okay, if you don't know it, write down, then please do make time to find out all these squares easily. Okay? Therefore, AC square is equals to 841 minus 441. Therefore, AC square is equals to 400, and hence AC is equals to 20 units. right? So we got AC is equals to 20 units here. That is our third required side that we didn't had here. AC is equals to 20 units. Now what do we require? We require cos theta, sin theta here in both the equations, right? And then we shall put it down in the equations that we need to find out the values. So now cos theta equals to what? So cos theta equals to, friends, we know that cos theta, the ratio for cos theta is side adjacent to theta divided by the hypotenuse. So here we will be having theta as this angle B, side adjacent to theta that is BC, and the hypotenuse that is AB. So here we can write down in place of cos theta that is equals to BC upon AB. What is BC, friends? 21, and AB 29. So directly we can get that cos theta is equals to 21 upon 29. Is this thing clear? So we got one of the ratio here, that is 21 upon 29, and sin theta, that is, again, what is the ratio for sin theta, friends? Sin theta, that is side opposite to angle theta divided by hypotenuse. So what is the side opposite to angle theta? That is AC, and here we can write down that is side opposite to angle theta, that is AC, divided by the hypotenuse, that is equals to AB. So what is AC here that we have found out? 20 units. So that is AC equals to 20 divided by hypotenuse, that is 29. So finally we get the ratio sin theta is equals to 20 upon 29, right? So we got these two ratios here, sin theta and cos theta. So the ratio of sin theta is 20 upon 29 and the ratio of cos theta is 21 upon 29. Now let us find out the values here. So first one, we need to find out the values of cos square theta plus sin square theta, right? Let us put down the values. We are having the values here, that is equals to 21 upon 29 whole square divided by 20 upon 29 whole square, right? Let us see that we can square these both the ratios here. What will be the square of 21? That is 441 divided by 841. We know that A upon B whole square, that is equals to A square upon B square, right? Because we can split out that squares for both the values, for numerator and for denominator both, plus 20 square, that is 400 divided by 841. Again let us add them. How can you add this both the ratios here, friends? Can you add them or not? Let me write down again. That is equals to 441 upon 841 plus 400 upon 841. Can we add these both ratios or not? Yes, we can add, but how? See, what is the denominator here? The denominators are same, so you can make a common denominator here. As we see in LCM, if the denominators of both the ratios are same, then we can make that denominator as common, and simply the numerators will be added. So that is 441 plus 400 divided by 841, which is equals to 841 upon 841, and hence this is equals to 1, because both the values in numerator and denominator are same. Therefore we got cos square theta plus sin square theta as 1. That is our first answer, right? That is our first answer, that cos square theta plus sin square theta is equals to 1. Now we need to find out the second one also. So let us see the second also. What is the second question? Cos square theta minus sin square theta. Again, let us put down the values here. Cos square theta. What is cos square theta? We don't have, but we have cos theta, that is 21 by 29 whole square minus sin theta, that is 20 by 29 whole square. Again, as we seen here, what the ratios had square, both the terms, that is numerator and denominator, both were made squares differently, and hence we get here 441 upon 841 minus 400 upon 841. See friends, the concept now that goes same, only the thing is here we had plus in the first question and here we are having minus in the second question, right? So again, this both are ratios with a subtraction. We can see that 841 becomes a common denominator and the numerator gets subtracted. So 441 minus 400, that is simply 41 upon 841. You cannot cancel out 41 and 41 and write down 1 upon 8. Don't make that kind of nonsense, friends. Right? So that is the answer. Hence, cos square theta minus sin square theta is equals to 41 upon 841. Right? And hence that is the answer of the given question, that is cos square theta minus sin square theta. So we got the answer here. The first one, that is sin square theta plus cos square theta plus sin square theta as 1, and the second one cos square theta minus sin square theta, that is 41 upon 841. This is how you can solve the questions related to the triangles with the given values, and hence finding out the third value or the third side and then finding out the given question. Okay. Now I am having one more question, friends. Let me erase this and then I am going to write down that question here. The example given to me here, the question given to me here is that in a right triangle, ABC, right angled at B, if tan A is equals to 1, then verify that 2 sin A into cos A is equals to 1. We need to verify that 2 sin A into cos A is equals to 1 for the given condition that right angled triangle ABC right angled at B, if tan A is equals to 1, then you need to verify this. So first of all, let us draw the triangle here. We got right angled at B. Let us take A here and let us take C here. So tan A is given as 1, so that is our reference angle, friends. Tan A given tan A equals to 1. So what is the ratio for tan A, friends? Side opposite to angle A divided by side adjacent to angle A. Yes or no? Therefore, side opposite to angle A upon side adjacent to angle A is equals to 1. So what is side opposite to angle A? BC. What is side adjacent to angle A? AB. Therefore, BC upon AB equals to 1. Let us say that is equals to K. Right? Let us say that this ratio BC upon AB equals to K. Therefore, we get BC is equals to K and AB is also equals to K. Because, why? Because this ratio here is 1. You can see that the ratio is given as 1. The ratio is 1, that means the numerator and denominator both will be 1 and 1. So the ratio of 1 is to 1 or 1, that is simply K is to K. So we got these two sides here as K. BC equals to K and AB is also equals to K. We got these two. Now what? Now we need to find out the values of sine A and cos A. So to find out sine A and cos A, we require the hypotenuse, because the ratio for sine A is side opposite to angle A divided by hypotenuse, but we are not having the hypotenuse here. So let us find out the hypotenuse. Now, in triangle ABC, angle B is equals to 90 degree. Therefore, AB square plus BC square is equals to AC square. Therefore, K square plus K square is equals to AC square. Hence, K square plus K square is equals to AC square. K square plus K square, that is 2K square is equals to AC square. Taking square roots on both the sides, this will give me AC is equals to root 2K. Right? This will give me AC is equals to root 2K. So we got the hypotenuse now, that is equals to root 2 into K. Friends, note that this K is not inside the root. This is only root 2 and K is outside the square root. Okay. So we got AC, hypotenuse now. Therefore, sine A, what is the ratio for sine A? Sine A is side opposite to angle A upon hypotenuse. Therefore, sine A is equals to BC upon AC. What is BC here? K. What is AC here? Root 2K. K and K can be cancelled, that is equals to 1 upon root 2. And cos A, that is equals to side adjacent to angle A divided by hypotenuse, that is AB upon AC, which is again, what is AB? K. AC, that is root 2K. K and K is cancelled, and hence we get this cos A also as 1 upon root 2. So we got these two values here. Is it clear? Now, LHS. What is the LHS of the question that we need to verify? You need to verify that 2 sine A into cos A equals to 1. So this will be our LHS. LHS, that means the left hand side of the equation that we need to verify or prove. That is 2 sine A into cos A, that is 2 into 1 upon root 2 into 1 upon root 2, which is equals to 2 multiplied by 1 upon root 2 into 1 upon root 2, that is 1 upon 2, because root 2 into root 2 is 2 and 1 into 1 is again 1. This 2 and 2 can be cancelled, and hence this is 1, which is your RHS of the thing, of the equation that we need to verify. Therefore, LHS is equals to RHS, hence verified. Hence it is verified that 2 sine A into cos A gives me 1 for the condition that if tan A equals to 1 in a right angle triangle ABC, right angled at B. So for the given situation here, we can say that this condition 2 sin A into cos A will give me the answer equal to 1. Is it clear, friends? So that is about this question here that we are going to, that we have already solved here. Okay, let us solve one more sum that is somewhat of a different kind. You need to apply a different logic, but that logic is nothing more than a Pythagoras theorem, and then we shall apply the logic of the trigonometric ratios. So the question here is, in triangle OPQ, right angled, at P, OP is equals to 7 centimeter and OQ minus PQ is equals to 1 centimeter. Determine the values of sin Q and cos Q. So first of all, friends, from the given question, we can draw a figure that in triangle OPQ, right angled at P. First of all, let us draw this figure. Let me draw a straight line. Right angled at P. So this is P. Let me take this as O and let us take this as Q. We are given that OP is 7 centimeter. Okay. And friends, we are given the second thing, that is the difference of OQ and PQ. That given OQ minus PQ is equals to 1 centimeter. We are not given OQ equals to 1 centimeter, neither PQ equals to 1 centimeter, but the difference of OQ and PQ is 1 centimeter. Therefore, can I write it like OQ is equals to 1 plus PQ, shifting this PQ here on the other side. So this minus PQ here will become plus PQ, and let me name this as equation number 1. Right, so OQ is equals to 1 plus PQ, that we have got from the given equation. OQ minus PQ equals to 1 centimeter. Now, in triangle OPQ, angle P is equals to 90 degree. Therefore, OP square plus PQ square is equals to OQ square. Yes or no? OP is given 7, PQ we are not given. Let us keep it as it is, and OQ that is given, that we have got it as 1 plus PQ. That therefore 7 square plus PQ square is equals to 1 plus PQ whole square. Now friends, you can see clearly here that all these terms in this equation right now are having only and only PQ. We are having only as PQ. So first of all, we will get PQ here. We will put PQ in this equation number 1, and hence we will get OQ. So let us simplify. 7 square, that is 49, plus PQ square is equals to This is read as a plus b whole square, 1 plus pq whole square. So the formula for a plus b whole square, that is a square plus 2ab plus b square. So we will apply that formula here, and that gives me 1 plus 2pq plus pq square. Okay, so we can cancel out this pq square and pq square on both the sides. Therefore 49 is equals to 1 plus 2pq. Taking this 1 here, we will get 48 is equals to 2pq, and again cancelling by 2 on both the sides, we get pq is equals to 24 centimeter. Okay, so we got one of the sides, that is PQ, as 24 centimeter. From equation 1, OQ is equals to 1 plus PQ, that is equals to 1 plus 24, and that is equals to 25 centimeter. So we got the second thing, that is OQ is equals to 25 centimeter. Let us confirm. OQ minus PQ equals to 1. So OQ is 25 centimeter, PQ is 24 centimeter. 25 minus 24 centimeter is equals to 1 centimeter is confirmed here, and hence the values that we obtained here are correct. Is this thing clear? So let us write it down here, that is 24 centimeter, that is 25 centimeter. We got the remaining, the values that were absent, that we didn't had in this triangle OPQ. Now once we get this values, let us find out the values of sine q and cos q. Therefore sine q, friends, see, our reference angle is not here now, our reference angle is here. So sine q, that is side opposite to q. What is side opposite to q? That is OP upon the hypotenuse, which is equals to OQ. And let us see the ratio of cos q also. Sorry, friends, cos q. What is cos q? Side adjacent to angle q. What is the side adjacent to angle q? PQ. So we will get this cos q is equals to PQ upon the hypotenuse, that is OQ. So we got both the ratios here. Let us simply put down the values. So OP, which is equals to 7 centimeter, divided by OQ, that we have got it as 25, and hence we get the ratio of sine q as 7 upon 25, and PQ, that we got it as 24 upon OQ, 25, and hence we get the ratio of cos q as 24 upon 25. So here we get the required ratios of sine q and cos q, as sine q equals to 7 upon 25 and cos q is equals to 24 upon 25. Is it clear, friends? So this is how we can find out the ratios for each and every given situations for the triangle. Is it clear? So let us keep it here for this lecture. In the next lecture, friends, again we will solve some important sums related to the trigonometric ratios, and then we shall move further with the chapter. Thank you.